Oops. Let's have fun, guys. Yeah? Good.
Yeah, they can hear you.
I know, I'm on. Good to go. It's time. Okay. I'm going to be over here. No, I'd be here. Okay. That's good. Yeah. Okay. Then. Good afternoon here at the Automatica. If I can get your attention, please, we're going to be starting the programming for the next panel here at the AI Society booth, the Robothon Insights Panel with our expert jury. So if you haven't already heard, we had a previous session this morning at 10 o'clock where we had our teams from the international competition present a little bit about themselves, and then we had a meet and greet over in our nice high-tech summit area. But now we have the chance to bring on our jury. So without further ado, I have my microphone here. I'm going to go ahead and let's have you guys come in closer, yeah? So I can make me feel a little bit more intimate, yeah? This will be good. If we have some open seats here in the front, it'd be great. So we have some bodies, that'd be really helpful, yeah? Make me feel more comfortable up here. I'll let you guys take your time. Okay, so with that, let's play the trailer, and we're going to have the jury members go ahead and come on up. Yep. Let's have two of you here. Yeah. Great. Thanks for the help with the hands. So I would like to start by introducing each of one of you. Thank you very much for spending your afternoon with us today. On my far right here, we have Professor Johannes Betz from the TUM School of Engineering and Design, Department of Mobility Systems Engineering, and also our jury member here. Thank you.
Hi, everybody. Nice to meet you.
And then directly to my right, Professor Patrick van der Smaakt from Volkswagen Group. Thank you for being here. He's the Director of Machine Learning Research at Volkswagen Group.
Thank you very much. Nice to be here.
And then on my left here, we have Professor Dr. Alice Ude, joining us from the Josef Stefan Institute, and also coordinator for the Reconcycle project. Thank you for being here.
Nice to be here.
And then on my far left here, we have Professor Dr. Julia Boras. Thank you for joining us. Institute de Informatica Industrial. Hopefully I get this right. Please forgive me.
It's okay.
Thank you for being here. Yeah.
Thank you.
So this session is all about how we make connections between what we do in the Robothon competition and our industry partners. Just to give a quick oversight, Robothon is an international competition that happens in a distributed fashion across 13 different countries around the world. We've been around for 3 years now. In the first year, we tackled single arm manipulation. In the second year, we looked at advanced manipulation. And in the third year, we did bimanual manipulation. All these tasks are tied to a real world problem that's motivated by industry and focused on industrial waste and e-waste handling and recycling. So in this year, we have the 2023 challenge where we put together a device like this one here on my left. This is a Robothon Challenge task board, and it has 6 different tasks that are representative of using a multimeter that a robot is supposed to use in a fully autonomous fashion. And why is this important? So e-waste is a huge problem for the global community. This is something that no matter where you live, you're generating e-waste, and it has to go somewhere. And so we really see this as not only a big problem, but also a golden opportunity. From the report from UNITAR, they have a global e-waste monitor. You can see that in different parts of the world, we have outflows and inflows of materials. And we're really trying to move towards a global circular economy where we can actually reuse and recapture a lot of the materials and precious minerals that are inside our valuable electronics today. You might see them in your phones, you might see them in your computers, on the screens here, and almost every technology demo here, we have precious metals and minerals that are being used. And where do we actually get those? Do we go from the rare earth minerals that we have to mine, or do we actually set ourselves up to think about the future and actually recover the material that we use instead of them going directly to e-waste landfills? So we're going to talk a little bit about how these boxes in front of you, here we have the one from 2023, and on the right we have the previous version in 2021. Both of these are inspired by industry e-waste tasks. On the right here we have a box that has a battery disassembly task, where we ask teams to actually take apart a battery box and actually recycle batteries in addition to inserting a key and doing an insertion with an Ethernet plug. These are very common problems in the robotic space. And so let's actually get some input here from our jury. But I would like to put this picture up on the back here. We started this from nothing 3 years ago, and I'm just so happy that it's grown into the wonderful community that it is here today. We have many of our teams in the audience. Thank you guys for coming from all over the world. In this year, we had 27 applications. We had to down select to 20 of those. Each of those teams received one of these task boards and then was able to demonstrate their robot platform, skills, and technology on a standardized problem from their own research labs, from their own countries, and it's so great to actually have you here in person today with us to discuss the challenge. So we actually have 56 of these running around in the world, and it's really become an important benchmark for robotics. So the last part before I move on to the jury, I just want to give the frame here. So the vision behind our competition is to be the bridge. We want to be an active part of the AI industrial revolution and to create the AI factory that has a circular economy in mind together. And so we do this through 3 principal goals. The first is to have reusable robot skills that are comparable in performance to a human, specifically doing parts that are related to e-waste assembly. Secondly, we want to build an active robotic community that is connected with industry and academia through our competition, through trade shows like this. Thank you, Automatica. And thirdly, we like to have a data-based way to evaluate how well we're doing. So we have a IoT framework that runs on top of these task boards that we can actually have a viewpoint into the activities around the world on our website. So feel free to check that out when you get a chance. And I'm going to leave it right here. So I'm going to just put this frame up here. How do we actually make all these goals and these visions happen? We have this workflow, which I show up on the screen here. We have I'll just walk you through the map. So in the center green box, this is what we talk about our competition. This is our contribution to the world. And on your left-hand side, we have human skills that are operating in the real world. And these are processes that are going on in factories today. And on the far left-hand side, we have the future skills of factories of tomorrow. And how do we actually get the skills that are so hard to capture from the human ability into the machines that will be working in the factories of tomorrow? We see this through our digital robot judge that's built on top of these task boards. And we do it through competitions like this. We have a first iteration where we collect problem statements from our industry partners and sponsors of what would be interesting for our teams to work on. And then we build a specific task board to hold these challenges. And then we distribute them through our competition. And as we can do this, we really take advantage of the open innovation model, where we can get new ideas that are outside of our organization, and we can really incorporate the huge diversity that we have in solving this global problem. And then thirdly, we can aggregate all those solutions together through our competition and through our IoT framework, and we actually create some competition results, things that the jury cares about. And so this is the way that we see our role in the world. And the blue part, this is all of you. This is the community. So we invite you to be a part of our journey, to iterate on the designs, to contribute new ideas, to really develop new skills for your robots and robot platforms, and also to tell us what is important to you. How do we evaluate? What should we be rewarding? And that's what we're going to talk about today. So with that, I'm going to go ahead and just do a brief highlight here. This gives us the frame. If you weren't with us last year, we had this box on our right. This is the competition. And so this competition box, as I said, is supposed to represent the real world problems. Now, if you don't believe me, we have, as part of the competition, a bring your own device challenge. So there's a point system that is associated to solving this task board, but then we also ask the teams to be a little bit creative and bring the problem that's important to them into the challenge and present it through this transferability demo. So what you see on the screen, there's a trial protocol here with our task boards. We give them a start and an end goal. Each of these has specific instructions for the teams to follow autonomously with their robots, and they get points based on the completion, and we are timing how well they do their work. And this is done by a human, and we can actually measure the performance of the state-of-the-art robots, the winners of Robothon, against the best human performance. This is a really good watermark, if you will, to see exactly where automation is today. So with this as a frame, I would like to share with us on the stage just a little bit of the impression, if you could. Professor Dr. van der Smaakt, could you tell us a little bit about how much these task boards really translate and capture from your view at Volkswagen in industry? How realistic can we actually transfer skills that teams are doing on these task boards into the industry, into factories today?
Thank you, Peter. Well, first of all, that one's much better than this one.
Why?
Right? Because of there's much more haptics involved in the board this year than it was in the board 2 years ago. And if you do open loop control and manipulation, which was possible for this one, it doesn't scale. Right, and that's something that I mean, being a DLR many years, and the thing I learned there is that robotics without sensing, vision sensing, tactile sensing, haptic sensing, doesn't make any sense. Doesn't scale to complex problems, right? And that's what this board starts doing. So I think it's a very important step. We might need some miniaturization, but things like speed, dependability, and quality of the solution can be showed by that. So I think it's a very good initiative.
Great. I think we have a slide. Let's just go through this here. So just to also kind of put this graphic up here, we have the discussion of transferability, and I want to get into the details of exactly what you mean on this. We can elaborate with the other jury members about skill transferability. So this is sort of the golden holy grail, if you will, for robotics, is how do we actually go from the usual case, which is a human programming a robot for a certain environment to do a specific task. And this is something that is done numerous times throughout every country. They iterate on the same problem, even competing with other companies for the same projects. There's so much energy being wasted in repeating this work. But how do we actually go one level above and abstract away the actual essence of the problem and then begin to build reusable skills? This is what the goal that we would like to do. Maybe just to walk you through the graphic here, on the left-hand branch, we have the embodiment change. So how do we go from two different robots embodiments with the same problem, the same environment, and actually translate the skills between those different robots? And then we have on the left-hand side the environmental change, which is where we have the same robot but in a different environment. This is, I think there was a good analogy between cars. Maybe you could elaborate about how we think about this with car analogy.
I'm not into cars, but if you want, I would rather extend that to production in general.
Okay.
Right?
Yeah.
Because then production needs much more flexibility these days, yeah. And that starts from production to production change to recycling and the whole process, and that's where I see that analogy.
Perfect. Thank you. Not to put you on the spot there. I think the car analogy is we have all cars. We know what roads are. But we drive in different situations, different environments, but we all know what a car is. But how do we get to where the robot is in the same idea? So how do we transfer the skills from one driver to another, from a truck to a van to a car? This analogy, I think I just wanted to kind of set the frame. And then finally on the bottom tier here is the general intelligence. How do we actually go from many different robots to many different situations? So this is, well, I'll just leave this up here. We're going to talk a little bit more about it. But maybe, Professor Boras, could you tell us a little bit more about the challenges that you saw with this task board and what were the solutions that we had from the teams? What stood out to you when you were doing the jury work?
Well, even though it was exactly the same task for everybody, we could see a lot of different solutions, like everybody could solve it in different ways. I particularly like when they actually did like these smart things that they used the prof as a tool then to open the door, and then another team actually used the cable to grab the knot of the door to open it, and that could save a lot of time. That as humans we know how to do it, so seeing robot doing it and maybe one day thinking that maybe one day a robot can get to these solutions alone, it's really like a very exciting possibility.
Yeah, yeah. I think it's absolutely right. I mean, we can demonstrate maybe exactly how to wrap the cable. Would you mind just demonstrating how to wrap the cable here?
Sure, but
So, as she's doing this, I'd like to introduce Professor Ude. If you could just share us a little bit about what you're working on. I think you're working on a very exciting EU project called Reconcyle.
Right.
Maybe you can share a little bit about exactly what that project is, but then also how does it relate to maybe what we're doing here at Robothon.
So the project involves also TU Munich, that's why I'm here, I guess. Yeah. And so basically in Reconcyle, we are looking at how to actually disassemble different electronic devices. So why do you need to do this? So in recycling, often they use something called crush and separate, where you just crush everything and then physically separate the valuable parts. But with electronic devices, you have these dangerous components like batteries, and this needs to be removed. And here you get a lot of interesting problems actually for robotics. So all these devices, you know, if you look at the smoke detectors or something like this, so there are thousands of different models, and you need to handle basically all of them, hopefully. So you need a lot of adaptation for this. So they can also, these are used devices, so at least hopefully we are not throwing away too many unused devices. So basically they can be damaged, and this again makes you problems at the control level. So you need to both at the higher level make plans how to disassemble the device you're currently dealing with, and then at the low level deal with the control issues that come up with when devices are not quite as you expect it to be.
Absolutely agree. And I want to get to, we actually have some video footage that we want to share, and then we can get to that and we can actually see some of the demonstrations that the teams have done. So thank you for sharing a little bit about the project. So just to quickly finish on that point, in the previous competitions, I know we're a fan of this board, but we had the human benchmark between the best teams in 2021 and 2022 working on with this task board. And we found that the human was really fast, sub 9 seconds. And the robots have done an incredible job in improving year over year, 110 seconds, 21. And the same challenge, but even with a sixth task, just 1 year later, down to 52 seconds. And the difference was, as you mentioned, this tactility it doesn't scale. They had to incorporate vision to actually realize this performance. But with these task boards, we actually get down to the task level to see where can we make those improvements. So even though 52 seconds, there's still a huge gap. How do we address this? How do we get humans to approach human performance? So as I've said before, we have this graphic where we work with our Robothon task boards. And here's me completing the different tasks in the loop. But I think I'm going to skip over this. We saw this already. And we're going to go to the competition demo reel. Here we go. This is going to be all of the teams presenting their transferability demo for our competition. Let's play the reel. Can we get the audio? Yeah, thank you. Let's get a round of applause, huh? Great. So I just want to share, this is a cross-section of the teams that are working in their own labs. They bring the inspiration from this board to their own problems, and we saw a complete diversity, what you saw, from simple battery voltage testing to complete motherboard verification and testing. So with this, maybe Professor Betts, you can tell us a little bit about why is it so hard, I think, for these teams to find a challenge that's appropriate, that they can actually build into a company of their own, actually bring it to the industry. What is different about the academic realm and industry? What are the different constraints, just to help us understand?
Yeah, good question, Peter. Well, first of all, congratulations to all the teams. It was just amazing to see all these videos. I think all of the jury members were smiling all the time, and I think gave some good recommendations for all of you. So to answer your question, I think one of the big hurdles right now, you came up with so good and crazy ideas, and maybe they are too crazy right now to bring them into a production-ready environment. For example, some of the teams use some algorithms, learning by demonstration, reinforcement learning for something like that, and achieved good results. And that's what research can enable, right? This environment, playing around, coming up with these crazy ideas. But now you need to do the next step, right? Is this a production-ready software? Is this production-ready? Probably not. But now you need to figure out how can you transfer these technology into, for example, your own startup. I think the research environment helps you to play around with different algorithms, with different software, and even running everything in simulation, then going to real hardware and learning from that, right? When you do that in a company, sometimes you do not have the time for that because there's a clear timeline where you have to walk through it, and this environment gives you the chance to do that, learn from that, and then bring it to a production-ready system. Yeah.
Completely agree. It has to be running 100% or 99.59s for industry, but
exactly.
It's really great. Again, I just want to highlight in the team journey, these teams around the world receive these task boards by mail and have a total of 4 weeks, 30 days to solve this challenge. In addition to that, do what they just showed you on the screen. So maybe, Professor van der Smak, could you just tell us what is important in the transferability aspect from the jury's perspective? What do we care about, and what's important for the teams to think about what are we evaluating then?
Well, you just mentioned it, like dependability, right? And from an industry point of view, you can have a very fast solution, but if it only works 99% of the time, who cares, right? Because you still need to have the human backup in order to cover that 1%, so you gain nothing. So you need to start off with 100% dependability, not possible in 1 month, all fair. And then, of course, high speed. So you need to have solutions which are fast, which work more than once, and then of course, right, which transfer to other domains, and that's why the bring your own device challenge was added there.
Yes.
So a combination of these three are the important things the jury went by.
Great, and we also, I think we have a formal rubric. I think we have a slide on that here. We actually have 3 parts that the teams are evaluated on. They have a documentation package that they submit, which includes a video of their team, a video of them doing the task board actually 5 times in a row for this robustness per se, and then we actually have them submit a repository of their code with a README of how to recreate their solutions. And then second, we have the live demo with all of you. And then we have the timing, as you said. This is really important. And Professor Ude, I know we also add some more curveballs to do some bonus points here. Maybe you can talk briefly about how we do flexibility. How do we evaluate flexibility in the competition here?
I mean, the flexibility should show basically that you can solve something that you have not programmed before, right? And so I would actually value the solutions that which are fully autonomous, because if you go to the industrial setting and something changes, so you don't actually want a programmer to come in. So maybe, I would actually appreciate more a solution which would be a little bit more general which would not be so general, but would just make small changes to the actual objects, and then show that you can fully automatically change from one solution to another. So this is, I think, maybe kind of realistic. I don't think we are yet at the cusp of the general AI that you need to actually program something totally different automatically.
And then we also asked them to reorder the tasks, I think, in the call, right? So this was the
Yeah,
curveball that we threw at them to evaluate how flexible their solution was. Yeah. So this is a breakdown of the scores. Shortly here, we're going to have the award ceremony that will be announced at 2:15 here. And we also have a special guest that's going to be opening for that. So I'm trying to keep us on time for that. But I do want to say, kind of in conclusion, just a huge thank you to the teams that are going behind this. We have incredible sponsors: Siemens, Huawei, Accenture, Conrad. Thank you for all the support, financial support, so that we can actually offer a huge 20,000 euros will be given away on this stage in just a few moments with that. And also our partners, Ka, Reconcycle, and EU Robin. Thank you for all your work, and we look forward to future collaborations. And with that, I would like to say thank you to all of our jury members, and we look forward to seeing you at 2:15 for the award ceremony. Okay, now we'll go down. Thank you.